Hi, welcome to my video on ways to prove a quadrilateral is a parallelogram. Ways to prove a quadrilateral is a parallelogram. One way, two pairs of opposite sides are parallel. So these two are parallel and these two are parallel. If we can have that, then we have a parallelogram. One pair of opposite sides parallel and equal. So this pair is parallel and the same pair are also equal. So we just need one pair equal and parallel. Two pairs of opposite sides equal. So this side equals this side and this side equals this side. If we have that, we can have a parallelogram. Two pairs of opposite angles equal. So this angle equals this one and this angle equals this one. Then we have a parallelogram. And the diagonals bisect each other. So if I draw a diagonal and I draw the other diagonal and they intersect here. So if I have this piece of diagonal equal to this part and I have this part here equal to this part of the diagonal, the two diagonals are bisecting each other. Therefore, I have a parallelogram. So let's prove some of those. And when we prove those statements, we have to do it in another way. After I prove them, or when I'm not proving them, I can use them in a proof. And you'll see that coming up later on in the next video that we do after this one. Let's do number one. We're given that angle 1 equals angle 2. And we're given that angle 2 equals angle 3. That's a given. We want to prove that A, B, C, D is a parallelogram. So the way to prove that this is a parallelogram, I'm going to prove it by two pairs of opposite sides parallel by definition. So if I put down angle 1 equals angle 4, and angle 2 equals angle 3, and that's reason is given, it's in our given, then as a result, 1 equals 4, I have AB is parallel to DC. And because I have 2 equals 3, that means I have AD parallel to BC. And the reason, that's I have angles equal parallel lines, so that's the converse of the PLT. And that's alternate interior angles equal. But because I have a pair of angles equal, 2 and 3, then the lines are parallel. That's the converse. And because I have two pairs of parallel sides, that means A, B, C, D is a parallelogram. You can either say by definition of a parallelogram, which is what it is, or we can say opposite two pairs. You can say two pairs of opposite sides parallel, or you can say definition parallelogram. So that's one. You can pause the video at any time to work these out. And notice now I'm making a statement. If a quadrilateral has one pair of opposite sides parallel and equal, then the quadrilateral is a parallelogram. So I'm given a quadrilateral, one pair of opposite sides equal and parallel. I have to prove. So let's name this parallelogram A, B, C, D. And I'm given that one pair of opposite sides are parallel and equal. So I have that AB is parallel to A, B, C, D. Make that a D. AB is parallel to DC, and AB is equal to DC. That's the given. And I have to prove that A, B, C, D is a parallelogram. And how do I prove a parallelogram? Well, I'm proving this statement, so I have to do the proof in another way. So what we'll do, we'll draw a diagonal. So number one, we'll draw DB. And that's a construction. We're allowed to join up D to B and make it a diagonal. As a result, we have a given AB is parallel to DC, given. And from that given, because these are parallel, I can have angle 1 equals angle 2. So angle 1 is equal to angle 2. And parallel lines, that's the parallel line theorem. And again, they're alternate, forming the Z, alternate interior angles are equal. And now we have number 4, we have AB is equal to DC, and that's also a given. I could have put all the givens in one statement, but I'm doing them separate. That's a given, that's a given. Spell it correctly. And now we have DB, or BD, is equal to BD, DB. Because angle 1 is equal to angle 2, B goes with D and D goes with B. And that's a common side to both triangles. Now we have AB is equal to DC given. We have angle 1 is equal to angle 2. We have DB equals BD. And now we have the triangles are congruent. So the triangles are congruent. Triangles A, B, D. And A goes with C. And B goes with D. And D goes with B. And that's an SAS, side, angle, side. Side, angle, side. SAS, congruency. And as a result of being congruent, so I can have, because these are congruent, I can say that angle 3 is equal to angle 4. So these two triangles are congruent. 3 is equal to 4. CP, CTC, corresponding parts of congruent triangles are congruent. And as a result of 3 equals 4, that means that AD is parallel to BC, and that's the converse of the PLT. We have two angles equal, we can have these two lines, AD parallel to BC, that's converse of the PLT, alternate interior angles equal. And notice now that we're given that these are parallel. We now have that these AD is parallel to BC, so that means that A, B, C, D is a parallelogram. And definition of a parallelogram, or you could say the opposite sides of a parallelogram are parallel. Two pairs of opposite sides parallel. So notice how I did the proof. I did this proof by getting two pairs of sides parallel. So when you do a statement and when you're given a statement and you do the proof on it, you have to do that statement in another way. And let's look at another way to prove parallelogram. A quadrilateral is a parallelogram. If a quadrilateral has two pairs of opposite sides equal, then the quadrilateral is a parallelogram. So we're giving a quadrilateral two pairs of opposite sides equal. So that means PQ is equal to SR. So PQ is equal to SR, and PS is equal to QR. So that's what we're given. We're given a pair of two pairs of opposite sides equal. There they are. And we got to prove that P, Q, R, S is a parallelogram. And again, to prove this statement, I have to do it by another way. I can do it by saying that opposite sides are parallel. I can do it by saying that one side is parallel and equal. Now, so how are we going to do it? Again, let's draw a diagonal. So we have, I didn't mark in my statement and reasons. Statements and reasons. Okay. And number one, we're going to draw SQ. And that's a construction. Now, we have the given, so we have these two sides equal. We have these two sides equal. And now we have this third side is equal to itself common side. So notice the triangles are congruent by S, 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 side, side, side. So we'll write down the given. PQ equals SR and PS equals QR. That's a given. And now we have SQ equals QS. SQ equals QS. And that's a common side to both triangles, equal to itself. And so that means, because we have the three sides, the triangles are congruent. So P, Q, S, triangle PQS is congruent to triangle RSQ. RSQ. P goes with R, so S goes with Q, and Q goes with S. You have the reverse. No, QS, S, or sorry, SQ, QS. You can't say SQ equals SQ, because it's not true. They don't fall on each other. So you got to say SQ, QS. And the triangles are congruent by S, S, S congruency. And as a result, let's name one angle. We only need one angle. So let's say angle 1 is equal to angle 2. CPCTC, corresponding parts of congruent triangles are congruent. And as a result of those two angles equal because of CPCTC, that means PQ is parallel to SR, and that's converse of the PLT, alternate interior angles equal. Because the angles are equal, because 1 equals 2. We have the parallel lines, and now we have that PQRS is a parallelogram, and the reason is we have these two sides parallel, these two sides are equal, so we have if a quadrilateral has one pair of opposite sides equal and parallel, then quadrilateral is a parallelogram. So we have PQ is parallel to SR and PQ is equal to SR. They're equal here, they're parallel here, so we have a parallelogram. So notice the proof is done by another way. So we can have the two opposite sides equal. Then we just proved that we have a parallelogram, but we did it by one side equal and parallel. Number 4. If a quadrilateral has the diagonals bisect each other, then the quadrilateral is a parallelogram. So we have a parallelogram. Nope, we have a quadrilateral that we're going to prove is a parallelogram. So let's have both diagonals intersecting at O. So the diagonals bisect each other. So that means that AC bisects EB, and EB bisects AC. So they're bisecting each other. That's the given. And we have to prove that A, B, C, E is a parallelogram. And how are we going to do it? Again, this is the statement. These are the statements, and these are the reasons when you go to do a proof. And number 1, we're given that AC bisects EB. Now I'm going to do them separate. I could put them all in one, but if AC bisects EB, AC bisects EB, so OE equals OB. So OE equals OB. Definition of a segment bisector. And we also have that EB bisects AC. And that's a given. So I did the two givens separate here because I wanted to show you that if BE bisects AC, that means that OA equals OC. And again, as you can see, this is number 3, this is number 4, and that's the definition of a segment. It's the same reason as number 2, but I just wanted to write this one down to get these two equal. Then I wanted to write this one down to get these two equal. So we have OE equals OB. We have OA, 2 strokes, equals OC. Notice we have, in this triangle, AOB and COE, 2 segments are equal. So let's put angle 1 equals angle 2. So angle 1 is equal to angle 2, and the reason is vertically opposite angle theorem. If 2 segments are intersecting, then the vertically opposite angles are equal. And because of that, we have triangle, a pair of triangles congruent. So we go AOB, dealing with AOB is COE. Notice that A goes with C and B goes with E, and the reason we have an SAS congruency. S side angle 1 OA, side angle side. So this side goes with this side. So OE goes with OB, they're equal. OA goes with OC, they're equal. Angle 1 is equal to angle 2. So we have a side angle side. And as a result of that, we have number 7. We have AB is equal to CE, CPCTC. And if we want, we could say this is angle 3. This is angle 4. So angle 3 equals angle 4. And that's CPCTC also. And because these 2 angles are equal, that means that AB is parallel to CE, converse of the PLT, alternate interior angles equal. So I have 3 is equal to 4. That means that this segment is parallel to this one, because this is a Z, alternate interior angles of 3 and 4. Now we have, notice we have AB is equal to CE. We want to mark it with 3 strokes. And we have AB is parallel to EC. So we have a parallelogram. A, B, C, E is a parallelogram. Because we have, if a quadrilateral has one pair of opposite sides, parallel and equal, then the quadrilateral is a parallelogram. And there are other ways to do that too, but this is the quickest way. If you want, you can prove that BOC, triangle BOC, is congruent to EOA by the same reasoning we did here with these two, and get that segment is equal to that one by CBCTC in this pair of triangles, and get both pairs of opposite sides equal. But this is I'm doing it this way, it's quicker. Okay, let's continue. And what about proving if a quadrilateral has 2 pairs of opposite angles equal, then the quadrilateral is a parallelogram. So I'm giving a quadrilateral MATH, and we have opposite angles equal, so that means that angle M is equal to angle T, and we have angle H is equal to angle A. That's given, and we got to prove that MATH is a parallelogram. So we have the givens. Angle M is equal to angle T, angle H is equal to angle A, given. And how are we going to do the proof? Well, we need to prove we got the opposite angles equal. We need to prove opposite sides equal. Can we do congruent? If I draw the diagonal here, I only have an angle, M equals T, and I got a common side, but that's all I have. So there's another little way to do it, and it's angle M plus angle A plus angle T plus angle H equals 360 degrees. And the interior angles of a quadrilateral, interior angles of a quadrilateral have a sum of 360 degrees. Because there's 2 triangles here. Notice, if I draw like that, HA, there's 1 triangle here and 1 triangle here. So 2 triangles together gives me 360. I'm going to use this, and here we go. Here, number 3. I'm going to let T be angle M. Angle M equals angle T, so I'm going to replace this T with angle M, and I'm going to replace angle H with an angle A. And that's substitution. And as a result of doing that, I get angle M, I get 2 angle M's, and I get 2 angle A's is 360. and that's addition. We're adding them up, and as a result, I can now, because there's the two common, I can say angle M plus angle A. Angle M plus angle A is 180 degrees, and that's division, dividing by 2. I'm dividing both sides by 2, and hence we have angle M is supplementary to angle A. Definition of supplementary angles. Two angles add up to 180, they're supplementary. And the reason for that, now I have, because M and A are supplementary, that means that MH is parallel to AT. And the reason is converse of the PLT. Consecutive, if we have a pair of consecutive angles, if the consecutive angles are supplementary, then the lines are parallel. Converse of the PLT, consecutive angles are supplementary. So if these two angles are supplementary, that means MH is parallel to TA. Now, that's one pair of parallel lines. So we can do the same again. We can say that angle M plus angle H equals angle M plus angle H is 360. So what we're doing this time, up right here, we're taking angle A and replacing with angle H, because angle A equals angle H. And we're also taking angle T and replacing with angle M. So this is done in number, again, we're doing a substitution here. And when I do the substitution here, I'm doing, this is 1 and 2. And when I do the substitution here, just got to be careful. I'm doing substitution in 1 and 2. So notice I'm replacing A with H, and I'm replacing T with M. So that gives us 2 angle M's and 2 angle H's is 360. And it's the same reason as number 4. It's addition. If I can spell it right. I haven't rolled it enough to spell it. And now I got 2 angle M, 2 angle H's. So angle M plus angle H is 180 because of division. And that means that angle M is supplementary to angle H. Definition of supplementary angles. And that means that because these two angles are supplementary, that means that MA is parallel to HT. And that's the same reason as number 7, converse of the PLT and consecutive angles are supplementary. So notice now I have number 7 and number 12, that MATH is a parallelogram by definition of a parallelogram, which means what? We have 2 pairs of opposite sides parallel. 7 and 12, we have 2 pairs of opposite sides parallel, so we have a parallelogram. Okay, we're almost to the end of this video. State the reason why each is a parallelogram. Give the reason. So we have, notice I have the same pair of sides equal and parallel. So the reason is that one pair of opposite sides are parallel and equal. That's why this is a parallelogram. And why is this a parallelogram? Because notice the diagonals are bisecting. The diagonals, sorry about that. Diagonals, notice these are equal, so the diagonals are bisecting each other. And here we have these two angles are equal, these two angles are equal, so we have two pairs of opposite angles equal. So we have two pairs of opposite angles equal, then the quadrilateral is a parallelogram. And right here, these are opposite sides are parallel. So these are a parallelogram by definition of a parallelogram, which means you have two pairs of opposite sides parallel, definition. And this one, these two sides are equal, these two sides are equal, so we have two pairs of opposite sides equal. So if we can prove that two pairs of opposite sides are equal, we have a parallelogram. If we can prove the opposite angles are equal, we have a parallelogram. If we can prove that the opposite sides are parallel, we have a parallelogram. Or if we have one pair of opposite sides equal and parallel, we have a parallelogram. If we can prove the diagonals bisect each other, we have a parallelogram. So these statements I will use when I want to prove a quadrilateral is a parallelogram in my next video that's coming up. And if you like my video, click on the like button, subscribe button, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Bye-bye.